Hey guys, welcome to another tutorial. Today I will be going over how to slice models so that you can 3D print them. And that essentially means that I'm converting the file from an STL file to G-code. So to start, we'll go to the top left and make sure that your printer is correctly input into Cura. This is important so that it knows the dimensions of your build volume. Next, I'm going to make sure the printer knows what material I'm printing with and the size of my nozzle. There are a bunch of different options, but I usually select generic and select the type of material I'm using. When you select PETG or PLA or ABS, Cura will upload default settings like nozzle temp, bed temp that will be needed for printing with the specific material you have selected. At the top right of your screen, there's a drop down for print settings, and that is where I'm going to tweak a lot of the printer's settings. I'll first start with the print quality. I usually select low quality because that prints my helmets faster, and I'm not too worried about the layer lines because I will be smoothing the helmet out after I finish printing it. The next thing I need to do is upload the file of the helmet that I'm going to print. I select that at the top left and find the file that I'm going to print. Today I'll be printing a Wrecker helmet made by Galactic Armory. Galactic Armory sells the files for many Star Wars and Halo helmets. They're really cool. You should go check them out. And if you do, use my code 3DELPRINT for a discount. Now that the file is uploaded, you'll see it appear here. If the file is yellow, that means it fits within the build volume and that it'll be able to print it. As you can see, there are some red markings on the bottom of the helmet, the undersides. That represents where, with the current settings, supports will be generated. And I'll go over where we want supports a little bit later. A lot of our tweaking and resizing can be done on the left of the screen with that little drop down with those little buttons. And also top right is where we're going to find a lot of printer setting options. So once again, we start with the quality. There's nothing much that I'm going to tweak here. Once again, for beginners to start, I think it's a great idea to start with the more generic default settings. Don't tweak too much, don't worry about it. And if your printer fails or if you're having issues, then you're going to want to change a few things. I personally like to keep the wall count to the default settings. In this case, it's 2, but if you're wanting a thicker, more durable helmet that will result in using more filament and being heavier, you can change the wall count, up it by 1 or up it by 2, however you see fit. Same thing with the top and bottom layers. The default is 4 and 4 for low quality. You can up that to 5 or 6 if you're wanting a more durable helmet. I do not recommend going lower. If you're super desperate to save filament on your print, then you can do that. But once again, I don't recommend doing that. And next is infill. It's more or less along the same lines. Depends on how heavy a helmet you want. I generally will change the infill amount to 5%. Default is 20%. A lot of people have heard that and have questioned that and said, wow, there's like not a lot, but 5 is fine. It works well. The helmet's not too heavy to wear comfortably on your head. So that's what I do. I use 5% and I change the infill pattern to gyroid. Gyroid is very satisfying. I think it helps with the structural integrity of the helmet. So that's what I typically use. And in terms of the material, that's where you're going to adjust the print nozzle temperature and the bed temperature. Default is 200 for the nozzle and 50 for the bed. I up it to 215 and to 60 because I like to print a little bit faster. And the next section is speed. So going along those same lines, if I want to print at a faster speed, I'm going to need a slightly higher nozzle temp. So I have printed at 70, but today I will put it at 65. Default, once again, is 50, but when you up it to 65, it will adjust all the other speeds accordingly. So that's what I'm going to use today. And once again, if you're just starting out, try to print with the default settings first. And once that works, or if it doesn't, then you can start tweaking things, getting the printer to print faster and whatnot. Experiment with it. Have fun. These are just the settings I use. Doesn't mean they're necessarily going to work for you. One setting that I highly recommend you use is the combing mode. It's under travel, and I turn combing to all. That means when it's going around the print, it will try to stay within the lines, which means you won't have as many little pieces of plastic sticking out of smooth surfaces, and it just results in less work for you afterwards. After travel comes cooling, and with cooling, I don't necessarily change a whole lot. I haven't dabbled with those settings, and I haven't really needed to change anything there. But once again, if you want to play around with it, feel free to do that. Everyone's printer is different. After cooling, we're going to tackle the support. Support is very important. You are going to need it with helmets because most helmets do not have a flat bottom. The visors need support as well. So I'll kind of walk you through what I like to do. In terms of support overhang level, that's important. We're going to play with that a little. I prefer the support pattern with lines. Support density does not need to be high. Remember, the density of the helmet itself is 5. I've been able to get 1% support density to work. Today I'll be using 2. But in terms of the overhang level, beforehand I told you guys about the red that you see on the helmet. The red represents where supports will be generated with the current support overhang setting. So when you change that, you'll see some red disappear, some red appear. And that means on those red spots, there will be support generated. So one thing that I like to do whenever I'm trying to generate supports is I want to make sure the whole bottom of the helmet, all the low points around that ridge are all completely red because it's going to print from the plate up, and that's the first spot it's going to need support. So make sure that all those ridges are red. Once again, the visor spot, the eye pieces, those inserts, those are usually an overhang that you need to support as well. The rest of the settings there under support, I don't really mess with. It's mostly the pattern, the percentage infill, and the overhang level that I change. After that, I will adjust the build plate adhesion. For helmets, I typically like to use a brim. It's attached to the support, and it's good for me to see on those first few levels if my plate and bed are level, because it will be coming out and adhering to the plate properly. The default settings are a little bit too big. I don't need it going around that many times. So I changed that to a lower number, and I don't need to worry about it being only on the outside because that lets me fit bigger helmets on the build plate. If you go back in the video, you would have seen that there was a gray border around the edge, and your helmet can't fit inside that gray border or above that gray border because the brim's going to be printed there. So when you remove the brim from the outside, it disappears and you can fit a larger helmet. Next thing I'm going to go over are the buttons on the left side. And many people have asked about how to block supports. That's the bottom one, but you have other buttons to move the helmet around, resize it, rotate it. So to start, you can move it. The arrows represent the X, Y, and Z axes. And like I said before, when the helmet's yellow, it fits. When it's this grayish color, it is not currently in the build volume and can't be sliced and can't be printed. So once again, you're going to want it yellow because that means it'll be able to print. Once you have the location right, you can play around with scaling. If you have uniform scaling set, you can change the entire size of the helmet to be bigger or smaller. You can also turn off uniform scaling, and you can play around with sizing that way to elongate the helmet vertically to the side. I don't really play around with that. I usually keep it uniform. There's only been one instance where I played around with those settings to get a helmet to fit my head correctly. It was with Galactic Armory's Rex helmet. That's the only time I've ever had to do that. But after you rescale or resize and have it fit on the plate, you can also rotate. And rotation can also be used to help fit the helmet on the build plate. what I like to do is, if the helmet's straight up, it's going to need to generate a lot of support to get to the bottom of the helmet. So I'll rotate it a little bit and then lower it so that there's not as much plastic waste. So you see the back of the helmet, that back brim is a lot closer. So there's going to be a lot less support created in order to make it up to the helmet. So once again, I have it yellow so I can see that it fits. It's going to use a lot less support on the back. The bottom side is still red. I'm going to tweak it, move it around a little bit, make sure that it's centered on the plate, not close to the edge, not too close to the edge of the build plate. So you just want to make sure that your helmet is correctly positioned on the build plate. Make sure it is sized to your liking. I'm going to make this helmet slightly bigger. I'm going to go to 102% because I have a slightly bigger head. I am 6'5", so I'll do that. Once again, you can see that it's still yellow. I make sure that it's not beneath the plate because then it won't print the very bottom. And as I double check this, I see that I can lower that bottom bit a little bit more to save even more filament. So I'm going to turn off snap rotation and I'm going to angle that and try to make that as flat as possible. Once again, as I rotate it, it'll lift it up a little bit. And I soon see that as I rotate it back, it's actually too wide front and back. So I'm actually going to undo what I did. It actually undid it all the way, so I'm going to need to turn back on snap rotation and get it back 15 degrees so that it's more or less where I had it. And then I want to make sure that that Z is set to 0 so that none of the helmet is below the bottom of the build plate. So once again, play around with these settings. Get good at moving your helmet around using the arrows, rotating it as needed, trying to find a way to minimize the number of supports you need on the bottom side of the helmet. In terms of minimizing supports, there are multiple ways to do that. You don't want to be using a ton of filament for each helmet that you print. The less filament you use, the more helmets you can make. So there are some specific areas that I like to block out. So underneath the dome of the helmet, it will always be shaded red. And that's something that we're going to want to block out. And like I said, it is the bottom button on the left. So we're going to want to just click on the bottom button, and then we're going to create a little eraser that's going to appear on the helmet. And at first, it'll be very small, but once we've selected it, we can use the same buttons above on the left side to change the size and shape of that blocker. So I'm going to use the uniform sizing, and I'm going to make that bigger. And then once it's about the size I'd like, I'll turn off uniform sizing, and then I'll adjust it accordingly. Once again, all the buttons work on this, so you can rotate it, you can move it, you can change the sizing and scale. How these blockers work is anything inside of the cube that you've created, the red that would normally be there will no longer produce any supports. So as you can see, I blocked out the red at the top. In terms of your overhang level and how you select that, once again, you're going to want that brim to be completely red. So I'll select the overhang level based on that, and then I'll go from there and start blocking out the other spots that I don't want support generated. So at first I start with the dome, and later on we'll go around and block out some of the other parts as well where I don't want support or need it. And I can make this look a little bit prettier by rotating it and moving it so it fits along the helmet a little bit better. And the reason I'm rotating it is, like I said before, I don't want to block out the tops of the eye insert where the visor is going to go, because that is an overhang that I need to have support. The dome itself, though, can be blocked. Most FDM printers can create that dome without any support. If you leave the support, you're going to be using a lot of support filament. So I always tend to block out the dome. your helmet will be fine in most cases, and just you got to trust your printer to be able to do that. The next step is to look at the other parts of the helmet and see what does or what does not need support. So once again, the red is where support will be generated. For sharp overhangs, I'm going to want to create supports. For indents that might be harder to smooth out, it'll also be worthwhile to create some supports there. On the inside of the helmet, there's a little red spot right there that I don't want support generated because the inside of the helmet doesn't need to look as good as the outside, and I think it's a steep enough arch that it won't affect the print of the helmet as much. So once again, I'm going to add that little blocker, and I'm going to adjust the size and positioning to block out all that red to the best of my ability so that support is not created right there. And once again, I will be using those top buttons to adjust the size, adjust the positioning. It does take some practice, but just work on increasing the size, moving it around to cover the parts that are red that you want blocked out. And remember, you don't want it blocking out other important parts like the bottom ring around the helmet and also the overhang where the lens will sit above the eyepiece. So you're going to want to make sure that those maintain the red, that they're not blocked out, but everywhere else you're just going to go around and essentially just adjust these blockers so that the red cannot be seen and that it's fit to your liking. I just wanted to remind you that this isn't necessary. You can technically load your helmet, put it on the plate, make sure it's yellow, add a steep or not so steep overhang, and just print the helmet without blocking out any of the red parts. The reason I do this, the reason I use the blockers to block out areas where I don't think the helmet needs filament is that one, I save on filament so that I can use that filament to print other things that I want. Two is so that in not printing those supports, the print will finish a lot faster. So if I have a print of a helmet that takes less filament and takes less time, I'm going to be able to make more helmets with more filament in the time that I have. And another thing to keep in mind is that when you have a longer print, more things can go wrong. A nozzle can clog, power can go out, and if your printer doesn't save your print with a power outage, then it's completely lost. If it does, it's still a whole process to find that your print stopped after a power outage and get it started up again. That just takes more time. So once again, the whole point of using these blockers is so that I can use less filament and have a quicker printed helmet. And another thing to keep in mind is that typically with 3D printers, the amount of filament that you'll be printing with is likely to be 1 kilogram or 1,000 grams of filament. That is the standard size roll. And if you're printing all those unnecessary supports, your print, once it's sliced, might end up being more than 1,000 grams, which means you'll have to switch out the roll mid-print, which isn't fun. Or you can do what I do, and regardless of how much filament you're going to use, how many grams, how many kilograms, you can buy a 5 kilogram roll from Xyltech, and you don't have to worry about switching out the rolls as often. So that's one thing that I do, but not a lot of people are going to be buying 5 kilogram rolls. It's usually 1 kilogram rolls. So just something to keep in mind is that you're going to want to slice it so that it uses less than that. And on this backside, there's a little overhang that isn't too steep. So I'm thinking that I can block that out just to have to avoid having to clean that up afterwards. So I'll just adjust my blocker, make sure it's big enough to cover the entire helmet, the entire width of the helmet, and then I'll just change the sizing and then eventually rotate it so that's blocking out the part that I don't want supported. Once again, I'm going to be careful not to block out the overhang of the eye insert, because that's important. I want that supported. I don't want that droopy looking like spaghetti. So make sure that that part of the helmet is in fact supported. But this other part I can block out because I don't need that. And it's good to always double check and make sure you are completely encasing the red. If you leave a little bit hanging, it's going to create an awkward little skinny support that goes all the way down to the plate. So just always double check, make sure you're covering the entirety of the red on every part that you hope to cover. It will save you having to redo and reslice your print when you're finished. So I could stop here and I could slice the helmet. I can use the slice button and the preview button at the top to get a good view of where the filament's going to appear and how it's going to be printed. But once again, always double check, make sure there are not extra spaces that I want to block. I've decided that I am going to block out a little bit of these pieces because I think they can print pretty well on their own. They don't need any support. The reason they're red is because I needed a drastic overhang level in order to get the entirety of the bottom of the helmet to turn red. So I'm going to block these out, make sure the support's not generated there because, in my opinion, I really don't think it's necessary. So with time, you'll have a good interpretation of what needs support and what doesn't. You'll know after multiple prints what your printer is capable of doing and where it might need help. There are little objects you can print. You can download some for free off of Thingiverse to use as basically test prints to understand to get a good visual of how your printer is printing out the objects, where it needs help, where it needs adjusting in terms of the settings and whatnot, overhang levels, different levels of extrusion and whatnot. So just something to keep in mind. It takes practice. You need to get to know your printer. You're not going to be perfect at it on your first go. It can get frustrating, but just have patience with it. Have patience with yourself. Practice. I always like to start with downloading free helmets or other objects from Thingiverse. Once again, everything on that website's free. And just practicing printing them out, seeing how they turn out. And after you get a good hang of slicing and using the blockers and whatnot, then look at other files you want, maybe from Galactic Armory or other places. And once you purchase those and are ready and feeling comfortable, then you can work on those, print those out, and you'll get good results because you've had practice. So once you have all your support blockers in, once the helmet is yellow and all the needed areas are supported, now we can slice. So just double check, make sure everything has red that needs it, and then you're going to click that slice button. This takes a little bit of time, so I'm going to hop off, but I'll show you guys what it looks like when it is sliced. So there you go. This is what it looks like after it's sliced. You'll see at the bottom right of the page the amount of time and the quantity of filament that you're going to use. I also already pressed the preview button. We were originally on prepare. It takes a second to load the preview, but once you have that loaded, you can see where support's going to be generated and how the print's going to look. The red is the helmet and the blue is the support that's going to be generated in those places that I left red. So same as before, you're going to want to go around, double check all the parts of the helmet, make sure that everything that needs support has support generated so that you'll get a nice clean print. So I can see those supports generated to get that overhang on the back. That looks pretty good. So once again, just going to go through and double check all the spots. That little thin arch looks like it was generated because it is underneath the brim of the eyepiece, the eye insert. So I can't really block that out because that's below, so it's going to generate that automatically. But the rest of the parts look pretty good. If there is something that doesn't look right, I can always go back and change it. So just for fun, I'm going to change the support type to tree. It was originally on normal. I usually do that. I've heard good things about tree, but we'll go through and we'll slice it again with the tree support instead. So here you go. You can see the support is slightly different. It will take longer and it will use more filament. What's interesting about this one is it looks like the support extends off the plate. I don't know why Cura did that, but ignoring that part, you can see that it's a little bit different. The outside's actually kind of messy, but generally with tree support, you'll get these little branches almost. That's why they call it tree, that will go and support areas that are needed. Underneath, it's a little bit better of representation. Just once again, it's these branches that are kind of sticking up and supporting the parts that are needed. I don't know why the outside generated so much, but in this case, in comparing these two slices, I think I will use the normal tree support or the normal support type for this helmet, as it uses less filament and it will take less time. So that's basically it. That's how you slice a helmet. Play around with it, mess around with the settings, use normal support, use tree support, rotate it around, find a good positioning. Get good practice at this. It takes time. Don't get frustrated when it doesn't work on the first go, but this is how you slice a helmet. This is how you convert a helmet from an STL to G-code. When you're done and it's sliced, you just save to disk at the bottom right of the corner. Once again, if it's not to your liking, you can always go back and change those settings and you'll just have to reslice. So one last thing that I like to do every time I finish a helmet is I like to rename it so that when I'm finding it on the printer, on the SD card as it's loaded up, I can see what helmet I'm printing. And I always like to add the amount of time and the amount of filament into the name, just so I know how long it'll take and how much filament will be used. So I change the name at the bottom left, and that's how I can kind of keep record of what it needs. But yeah, that's basically it. Thanks guys for watching. If you guys have any other questions or want to see other content or tutorials, please let me know in the comments. I'll try my best to respond to them. But that's basically it. Thanks guys for watching. Please like and subscribe if you want to see more stuff like this. It really helps out. And I hope you guys all have a great day.